Hey there, everybody. Welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho. And thanks for tuning in, by the way. Congratulations on finding our channel. We're looking at sunspot 2824 here in a composite set of wavelengths. We're looking at 335 and 211 angstroms, faded for your viewing pleasure. It's from the Solar Dynamics Observatory, and let's take some more looks at the closest star here. How about the colorized magnetogram? Sunspot 2824 does indeed still have the capability to produce significant solar flares. We could still see coronal mass ejections sort of in the Earth-facing vicinity. And there may be some new sunspots forming in the south as well. This area here never really had umbra long enough to get named a sunspot. Here's a full disk view in one of the ionized emission spectral states of iron. It's 193 angstroms. Coronal holes rotating past the Earth-facing zone here in both hemispheres. Actually, the one in the north is not quite Earth-facing yet. And here's 304 angstroms ionized helium. We've also got some significant activity rotating in, currently in the vicinity of stereo A. We'll show you evidence of that a little later in the video. So next thing we'd like to show you here at the Smash News Network, least busted name in news, is a diagram of the solar system. Here's where objects are currently. There's where things will be in 1 week. It looks like a full moon on the 27th or 26th. As we count down to the solstice, where will you be at the moment of the solstice? We'll be streaming live. And the solstice, by the way, is Sunday, June 20th at 11:32 and 9 seconds Eastern Daylight Time. Here's a star chart. Feel free to pause the video if you need to. The yellow line there is the ecliptic. You may see Jupiter and Saturn if you're up before dawn. Radio flux currently at 76 solar flux units for the radio flux right now. Here's a 1-year chart of that from solon.info. As cycle 25 takes its time in producing lots of activity. The red line below here, that's the sunspot number. NOAA not forecasting any geomagnetic unrest here in the next 3 days. And we see an ongoing earthquake lull. So we see a lull in 7 magnitude earthquakes here, folks. We're pushing 2 months. In fact, it's exactly 2 months since we've seen a 7 magnitude earthquake. And let's take a look at the breakdown here. I like to use volcanodiscovery.com's earthquake tools. You can sort by magnitude. And we saw some 5+ magnitude quakes in the past 24 hours. Nothing over a 6. Nothing even at a level of a magnitude 6. There was a deep quake in Peru. And I'm just going to scroll up the list here. Also, Argentina saw a deep quake. That was a 5.0 at over 190 kilometers depth. And let me just continue to scroll up the list here. Here's a deep quake also. A very deep quake at Argentina, nearly 600 kilometers depth for that one, and quite far inland on the South American continent. As you can see on the map, looks like a 5.5 may have been the largest quake of the past 24. That one in the Southeast Indian Ocean. Also, Timor-Leste saw a deep quake at a 4.3 magnitude. Tonga saw a 5.0. And Chile saw a deep quake here, a 4.0 magnitude, closer to the coast. as we did the show prep. Let's see what's going on with volcanoes. Mount Abico on Paramushir Island has been erupting and producing a 10,000-foot ash plume. Fuego in Guatemala exploding. Looks like a volcanic downtick here. We've only got 5 volcanoes on the list. 4 volcanoes on the list. I've learned to count. Sangay exploding as well in Ecuador. That's a 20,000-foot ash plume there. And intermittent puff emissions are enough to produce a 24,000-foot plume of volcanic ash above Sabancaya in Peru as it explodes. A great reminder not to pole vault the caldera. Don't make Steve Stimpak's ghost come and haunt you by pole vaulting a caldera. It's an unsafe thing to do. This public service message brought to you at massive personal risk and expense from smAshomash.com. Next, the GOES X-ray flux, showing no major flares over the past, really, 3 days, although we did see a minor C-class flare here on the 18th. GOES proton flux is still flatlined. No coronal mass ejections, significantly striking the Earth geospace, where it can be measured at the GOES 16, which is in a geosynchronous orbit, by the way, at a very high altitude geosynchronous orbit. Here's the GOES magnetometer. And I'm expecting a coronal hole wind stream to show up here in the next couple of days. But in any case, there's a 3-day chart of the GOES magnetometer. And for you new viewers, the N's and M's, those stand for noon and midnight local time for the satellite. Next, I'd like to show you this activity kicking off here around stereo A. So if you put your attention on this area right here, you're going to see a huge magnetic bubble form there, an indication that perhaps we're seeing some activity form almost directly in front of stereo A. We're not going to worry about the imagery in this video. Perhaps we'll make another video later in the day about this. You see that massive magnetic bubble form there right at the end of the video. Let's bring up the latest image so you can get a better look at that. That looks like a massive sunspot forming there. Just to the east of stereo A. Here's a line of sight ecliptic plane field plot. The last one was the top view ecliptic plane field plot. And the North Pole current sheet is approaching. By the way, we can expect to be in the North Pole current sheet sometime late in the day tomorrow, or perhaps on the 22nd. And indeed, this bubble here, this may be actually associated with sunspot 2824, but I don't think so. Because again, if you look out here, the source of this is east of stereo A. Lastly, the line of sight coronal hole plot, showing you the sun's B field in blue. Let's see if the latest image shows any oddities. Not really, but we do see some progression here. The sun's B field being drawn down toward the south solar polar region. Here are the detected filaments and sunspot groups. Again, sunspot 2824. The trailing umbrae aren't that big, but it is at least a beta class sunspot still, as we do see trailing south pole umbrae. The leading umbra is North Pole. And again, we do see some filaments in between Earth and Sun. We could see a coronal mass ejection sort of in the Earth vicinity. KP index currently at 2. And let's take a look at the real-time solar wind. So we just saw a mild uptick here in the solar wind density and speed. Current solar wind density slightly elevated here at around 18 protons per cubic centimeter. Solar wind speed 360 kilometers per second. Here's a geospace movie. A movie of the magnetosphere. This is based on the space weather modeling framework. It's 4 hours of data. In this slightly increased magnetohydrodynamic pressure environment. We'll also show you ground magnetic perturbations. Coming a little closer to home here. Here are changes in the Earth's B field. We showed you the sun's. Here are the Earth's B fields, or at least changes in the Earth's B field. The B field, by the way, folks, is the field that goes through the magnet. And we may be seeing some auroras kick off here. Also seeing some magnetic pulses here out of the western Pacific and across the Indian Oceans. I'll let it play through a second time. And welcome to the geomagnetic excursion. Next, thanks to our new subscribers over on YouTube, youtube.com/smAsho. Don't forget to check our playlists. We do a lot more than the daily space weather here on the channel. We're also on BitChute. There are exclusive videos there. Thanks to our patrons, the true source of funding for the content. If you'd like to see these videos continue to exist, please consider becoming a patron. We try to make them as timely as possible. We give our patrons all sorts of updates that nobody else receives, as well as science information and multimedia and more. For the earliest alerts in the world, become a patron at patreon.com/smAsho. The financial incentive received from our patrons is incentive for us to provide the most timely data that there is. Also visit our own website, smAshomash.com. smAshomash.org will redirect you. And check out our forum as well, smAshomash.com/forum, and let's talk about our mission. So we saw the writing on the wall a couple years ago. That's why we created smAshomash.com. It's part of our mission, which is to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects, to connect and consult with media organizations to multiply our reach. Hence videos like this one, to demonstrate cutting-edge proof-of-concept solutions to problems. We'll talk about that in a later video. To publish scientific papers in a multidisciplinary manner, including but not limited to sciences like spectroscopy, geology, etc. To assist mankind by advancing the study of predictive phenomenon in order to optimize value, reduce risk and liability, and save lives and resources, and adapt no matter what the adversity is, and to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion. So that's our mission. If you want to share that with anybody, it's smAshomash.com/forum/mission. Today's cosmology segment is going to be short and integrated into the daily space weather video. Let's get to it. So we've picked a random number 981, which is a BL Lacertae object, a type of full-spectrum quasar. It's quasar B2136-428. Here it is on the Chandra X-ray scope. Let's take a look at it on the 2MASS. And there it is in infrared light. It's today's, quote, random and, quote, object. Take a look at it on Pan-STARRS. It's not showing up on Pan-STARRS. How about on the DSS-2? There it is in blue light. You can see the way it's a little bit off-center, an indication that probably there's a galactic scale jet that is not aimed directly at us, the observer, but off to this direction a little bit, which is why the crosshair is not on the center of the light source there. Let's go back to the 2MASS. 2MASS showing you some indication of that also. 2MASS infrared light. And we'll show you the X-ray outputs from quasar B2136-428. There are the daily and 16-year X-ray outputs from it. And here's the 30-day chart of its X-ray bursts. Today's astronomy picture of the day is M13, a globular cluster. And this one is visible to the naked eye. And that area is about 150 light years in diameter. And that's located at about 25,000 light years. And that's today's cosmology segment. Let's get back to the Earth geospace. Next, talking about Van Allen belts and electrons. Here's a diagram of that with distances in miles. Electrons can charge up satellites and cause them to shut down to prevent themselves from being damaged. We do see some mild surface charging hazards here over the Caribbean and Central America. Here's a 1-year chart of the electrons that surround Earth. By the way, these are measured by the GOES-16 through radiography, and the measurement happens at about 300 kilometers of altitude. That's where the F-ionosphere layer is located. Here's the 3-day GOES electron flux chart. Normal, moderate ranges there. And here's the forecast model. NOAA expecting continued flat levels of electron flux over the next 3 days. No arguments here, as activity has been quite weak. Low levels of activity from the sun. So here's a visualization of the total the total electron content forecast. It's the whole air column from your handset to your GPS satellite, showing you where errors are likely to occur. And we see chaotic Van Allen belts once again. So surprising levels of electron flux here over nighttime portions of the planet around the Earth, around the equator. The most likely spot for GPS errors, sometimes even at nighttime. Here's another diagram of the atmosphere. We're showing it for this F layer right here. And now we're showing the F-ionosphere layer. It's in some ways the bridge between space and Earth. And you're looking at vibrational frequency here measured in megahertz. This ionogram brought to you by Australian Government Bureau of Meteorology. There's actually an interesting story in today's meteorology segment about the connection between the ionosphere and lightning. We'll get to it. First, the latest image. There's the latest image from 7:45 Universal Time. Here's your weather.gov map. Here are bonus features for your daily space weather. We're looking at the hydrogen alpha imagery from the Lurmouth Observatory in Australia. There are lots of filaments in between the Earth and Sun right now. The likelihood of coronal mass ejections is actually kind of high in the Earth-facing vicinity. There is activity rising out by stereo A. Sunspot 2824 has gained in complexity a little bit. We'll show you in a moment. And if we do see a coronal mass ejection, we will let you know. Here comes some additional bonus features. It's the intensity gram, and you can see there is a little umbra here that started to form here. That's a North Pole umbra. That's a South Pole umbra. And this main umbra here, that's North Pole. So continues to be a beta class sunspot. There is the colorized magnetogram. Here's a 24-hour animation in 304 and 1600 angstroms. So you're looking at ionized helium and ionized carbon in this view. A composite. Here's another composite. This is 2 ionized spectral states of iron, 193 and 171 angstroms from the Solar Dynamics Observatory. And last but not least, here is the highest temporal resolution. The 2 wavelengths that take 10 images per minute instead of only 2, 131 and 94 angstroms. Also both ionized spectral states of very, very hot iron there on the surface of the sun. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, and may that solar wind be at your back.